There is a cardiovascular risk factor in the background of your workday that involves no calories, no physical exertion, and no visible symptoms. It is the ambient noise of the workplace. While the connection between loud environments and hearing loss is well documented, a more complex question remains: how a sound wave vibrating through the air can translate into a spike in blood pressure. To find the link, we must look at the specific physiological impact of these waves, the reasons why massive scientific data sets seem to contradict one another, and the objective steps required to shield the heart from the environment. This contradiction between the data and our own senses reveals the true scale of the risk. Evidence for this risk is found in a high-quality meta-analysis of 24 epidemiological studies, specifically tracking how workplace noise correlates with arterial hypertension. The data identifies a specific threshold where the risk begins to manifest: 80 decibels. This chart plots hypertension risk against noise intensity. From 80 to 85 decibels, risk curves upward. At 85 to 90 decibels, risk nearly doubles as sound intensity increases. This trend remains consistent, showing no difference in how male and female blood pressure responds. Under strict objective measurement, the relationship is completely clear. Higher decibel levels directly correlate with an escalating physiological stress response. However, this clear correlation seems to disappear entirely when we look at the Canadian Health Measure Survey from 2012 to 2015. This was a massive study of over 6,000 adults, combining detailed interviews about work environments with direct physical assessments of cardiovascular health. After adjusting for other factors, researchers found no association to blood pressure, no link to heart rate or to insulin and lipids, no connection to heart disease, to diagnose strokes, or blood pressure medication. We are left with a conflict: one meta-analysis showing doubled hypertension risk and a 6,000-person study showing no risk at all. The discrepancy comes down to how the noise was measured. While the first study used objective decibel thresholds, the Canadian study relied on self-reported exposure, how loud the workers felt their environment was. This points toward a biological disconnect. Through psychological adaptation, the human brain eventually filters out constant background noise, leading a worker to perceive a loud environment as normal or unobtrusive. But the autonomic nervous system does not share this conscious adaptation. Even if you no longer feel the stress of the noise, the body continues to react to the physical pressure of the sound waves, keeping the heart in a state of high alert. Because we can't feel this internal stress, our own subjective perception becomes a poor tool for gauging the actual physiological impact on our cardiovascular health. Since we cannot rely on our internal sensors, protecting the heart requires us to look past our own comfort and rely on objective data. You can start by using a decibel measurement app on your phone to get an actual reading of your workspace. Take these readings during the peak of your workday, when the environment is at its busiest and most chaotic. If those readings consistently exceed 80 decibels, the data suggests that physical interventions, like high-quality earplugs or noise-canceling technology, become a necessary health measure. Objective noise above 80 decibels creates a measurable spike in hypertension risk, even if your brain has learned to tune the sound out. Safeguarding the cardiovascular system from this specific threat requires measuring the environment as it actually is, rather than how we perceive it. Taking steps to physically block these sound waves is a direct way to mitigate a hidden risk to your heart. Consider checking your own environment tomorrow and help a coworker do the same.